patterns are very useful to us because they can help us solve some problems, because we can use these patterns to be able to predict things. But they're also very important to us in terms of being able to solve some very complex mathematical problems as well, which we'll see when we get to calculus. So some examples are Fibonacci sequence. This sequence can be found in nature in all sorts of places. For example, in flowers, in the way things, how branches bud. So for example, if I have a branch here like this, the buds on a tree often form, the spacing often forms a Fibonacci sequence. Okay? And these things, this is just one of many places where the Fibonacci sequence shows up. The harmonic series is another one. So the harmonic sequence here is just 1, 1/2, 1/3, 1/4, but this shows up in music all the time. So the harmonic, the pentatonic scale is based, I think, on this harmonic sequence. So what are these patterns and how do we use them? Well, ones that we've looked at already are arithmetic sequences and series. So arithmetic sequences are just a progression where we just kind of add on the same amount, or repeated addition, and they follow a linear pattern. So if I were to graph an arithmetic sequence, we can see that they go up in steps like this. Okay, and our steps just is going to be represented by, so if this is n equals 1, 2, 3, like that, the steps are going to be indicated by this common difference. So we go up by d each time we go across by a certain amount. So we can see that this is very similar to how linear sequences or linear functions work. So we can see that also that this must be connected somehow to linear function, which it is. And we can see that this would be the slope. This would be some starting point. So this arithmetic sequence can be modeled by a linear equation. And when we add up this sequence, we end up with a series. In arithmetic series, we end up with these two formulas. Essentially, they're the same formula, but the sum of the sequence or the series can be calculated using this formula where we add the first and last terms, and the sum of the first and last terms is going to be consistent when we work from outside in when we add up the series. And we could also replace that L with the Tn formula, and we end up with this formula here. And if you look very closely, this ends up being a quadratic formula. So this, in the arithmetic series, progresses in a quadratic fashion. So the series represents the sum of sequence, and it's very useful for us because we use this in calculus. In particular, the harmonic series is something that we will use and we see often in calculus.